Hi, my name is Liz Hayter, and my partner's name is Alex Shen. This is our senior design presentation for the end of semester 1 of senior design. For our senior design project, we have chosen to do a robotic arm due to our advisor being really enthusiastic about this project, and we were really interested in it as well. And we decided to name our robotic arm Fred for standing for the future robot of essential demand. So, Fred is a robotic arm designed to specifically pick and grab requested objects off of a shelf or out of a bin. Fred is enabled to do the following. He can locate an object through a QR code sent to him. He can measure objects with computer vision, determining the size of the gripper to adjust to. He can pick up the item and place the object in its desired location. So, to make this a marketable product, Amazon actually is on the market for this process to be developed. So, in Amazon warehouses and any other retailer, large warehouses, since Amazon is the largest one, the hope for the future is to have a completely automated warehouse system to speed up shipping processes, reduce the cost of labor, or maybe have less employees during a pandemic and have robots do everything. So, Amazon created the Amazon Picking Challenge for college students and high school students to find a creative solution to, issue that they have. So, this is what inspired our project. We are sort of basing it off the rules of the Amazon Picking Challenge. Most of all, we've seen what other students have done, and ours is a bit unique to many of the designs out there. And we also wanted to learn more about robotics. So, this is the model that we will be using. We have 5 different joints. Joint 1 and joint 4 move, up and down. Joint The rest of the joints are more of, actually, that's backwards. Joint 1 and joint 4 move left and right. The rest of the joints move up and down. And then we have our standard gripper here. These are all powered by the Dynamixel. This is kind of the mid model of the Dynamixel series actuators. What we actually plan to do is put in 2 actuators here and 2 actuators down here. So, kind of at the elbow and the base of the arm. And doing that, we do have to modify the design in certain spots. Adding another actuator in these 2 places will hopefully increase the strength of our gripper, of our arm overall. I wanted to add as well that much of the frame is 3D printed. Pretty much all of it besides the gripper. Of course, not the motors and the railings here, but the outer, shells of the joints and the base here are all 3D printed parts, which we are on hold for of 3D printing right now, as we had access at 2 different locations that are both closed at the moment. What we will be making to the original framework design are modifications to the sizing of this railing here. I want to make this end from this end instead of the previously this was measured at around 6 inches. This comes to close to 10 inches and a little over 10 inches here. We want to adjust that range due to the range of our camera sensor. Our camera sensor works best at a specified range for measurement. It works at distances further away, around 2 to 3 feet, rather than objects right in front of the camera. So we need to make that modification. Hopefully, we're still able to get power with the extended arms. So here is the basic process of our system. Fred will receive an item request, and it will locate the item through the QR code. So each item will have a QR code placed on it. Fred is also on a linear rail, so it can move from left to right. It cannot move up and down. It will scan and measure the item. So this is an important goal for our project, is for the gripper to be able to grab a small item such as a Coke can and not crush it. So apply the correct amount of force. It will also recognize the object's mesh, meaning it will recognize its shape. So again, specifically for a Coke can, it sees that shape and it recognizes what the object is, and the data is sent to communicate of what size to open the gripper. It will continue to extend the arm and grip, like I just said, and then it will bring the item back to its desired location. Just like in a shipping warehouse setting, as we saw in the previous picture. So here is the full communication system with our robotic arm. We have a linear motion system, so we can sort of simulate an aisle in a warehouse. The linear motion system, although can communicate with a robotic controller, we are using the U2D2 controller. Of course, the robotic controller goes back and forth communicating with the robotic arm, which is controlled by the master controller. The master controller running ROS ties everything together, as it is taking the image processing data from the depth sensor, communicating that to our arm and to our controller. I have added more details on each of these individual parts in our final update, as I did not want to put a bunch of that information into here. So this is just our general outline of our communication system. I did want to add more details onto the RealSense camera for object recognition, as it is one of the, I guess, larger portions of the project. So far, we haven't really been able to create anything yet. It did take a while for us to get this specific part due to shipping issues. But I have been able to connect this camera to the ROS system, to the Raspberry Pi. I've been able to see the depth capability that it has. So this is essentially what it can do, is image processing. It can view the depth of images, and it can also track movement, although that isn't really important in our project. Here, this is actually ran in my room. I was testing the distance of the accuracy of the camera. So this is just a pack of mints, and it is about, and I marked it here, about 3.5 feet away from the camera sensor. I also did this during the day, which is when it seems to work best. Dr. Venke told me to actually measure the distances of the accuracy of the output we are getting here, as I have mentioned before, we had to adjust our design to the output we were getting based on our measurements here. So here is our project progress so far. For the first 2 months, we spent most of our time really learning the platform of ROS and how to operate it, how to control motors with ROS, how to set up the libraries in ROS, the ROS system is very unique, or at least for an electrical engineering major, maybe not so for Alex as a CS major. although it was a bit of a learning curve for both of us. And Dr. Venke even encouraged us to spend most of our time adapting to that. At first, I wanted to also design the frame in CAD, not all of the frame, but most of it. But since we had to leave campus, I decided not to. And then also the computer vision aspect of the project, we wanted to be prepared for, especially with the Intel RealSense camera, and be assured it is the proper sensor needed. So that's how we spent the beginning of our project. Once we got hardware in April, Alex began testing the motors, and then going from Arduino into the ROS environment. And I was tasked with doing the object recognition and measurement part with the Intel RealSense. I also did find a simulator for the robotic arm, and I'd also finalized the design and sizing of our arm. To conclude, this is how we will be moving forward. I just put the timeline for the summer. For the rest of the month, I will continue to work on specifically the image processing with our sensor, as we want to be as accurate as possible. We have looked at many different open source tools for this. I mentioned getting the mesh images of objects. There's also a base code for measurement that I have shown. I will be testing both of these resources as well as more to see what would work best for our specific project. And then Alex will continue working on the actuators and the motors, and hopefully by the end of May, we will be able to end social distancing and meet, and then we can hopefully speed up the process. In June, which is when I hope we have access to our 3D printers again. There's many 3D printers on campus that we have access to. Hopefully we can begin 3D printing those necessary parts. If by June we don't, I do plan on ordering parts. I also want to get a hold of the gripper by June so we can begin interfacing the measurement camera and the accuracy with the gripper and seeing exactly what the biggest challenge will be there. In July is when I plan to assemble the full design of our arm, and when we can actually begin the full system testing. End of July, also hoping to develop the QR code system to make it as if it was a real sorting system for a warehouse. In August, put in the railing and everything, which will be more of a mechanical issue, and then troubleshoot and move on from there. And that is a summary of this semester's progress. Thank you.